Hello everybody, and welcome to exercise 2 on page 11 of the workbook. Let's read this problem together. So they're giving us the position of a particle after t seconds, telling us that it's given by the function f of t equals 2 to the negative 2 to the negative t meters. And they'd like us to complete the table below with the indicated average velocities. Then after we do that, estimate the instantaneous velocity at t equals 0. Okay, so let's start with the average velocities. There are 4 of them that we're being asked to calculate, and we'll start with the average velocity involved with a value of h of 0.1. How would we do that? Well, first we have some notation for the average velocity that looks like this. So we want the average velocity over the interval from 0 to h, which would be 0 to 0.1. Okay, and then we have a formula for average velocity that just is the same thing as average rate of change. So we're going to take the change in our outputs, f of 0.1 minus f of 0, over the change in our inputs. There's our formula for average velocity. Okay, and how do we do that calculation? Well, 0.1 is an input value. It's a value of time. And so we're just going to take that 0.1 and substitute it into our function for t. Okay, so we're going to get t to the negative 0.1. We just took the 0.1 and substituted it in for t. And then f of 0, same deal. Okay, that's going to be 2 to the minus 0 if we substitute it in. Okay, and from here, idea would be to go to your calculator and just see what this works out to be. I'll let you punch that in and confirm that you're going to get about negative 0.670 if we round off to 3 decimal places. Okay, so that's our first entry in our table. Okay, and the rest of these entries are the same, just the numbers change. So the next one, value of h is 0.01, so we're interested in the average velocity between 0 and 0.01. Okay, that's going to look very similar to the calculation that we did before, just that the value of h is different. Okay, so this time, if we substitute that in, we're going to get 2 to the negative 0.01 minus 2 to the negative 0 over 0.01. Okay, and you can go to your calculator and confirm that this time you get negative 0.691. Okay. And we just continue the same way down our table. So average velocity between 0 and 0.001. Okay, I'm going to maybe jump straight to here because these calculations start looking the same. This time we're just going to get 2 to the negative 0.001. Okay, that turns out to be about minus 0.693, and the very last one, okay, what you'll discover is that you get the same number of negative 0.693. Okay. So we'll plug those into our table here. And we have now answered the first part of the question. We got 4 average velocities, okay, and we put them in our table up there. Okay, now what about the second part of this question, the instantaneous velocity of the particle right at t equals 0? How do we figure that out again? Okay, well, remember how we approached this problem in an example that we did earlier. Finding the instantaneous velocity is like finding the average velocity over smaller and smaller time intervals. And that's exactly what our table does. Okay, looking at these average velocities, we're taking average velocities over smaller and smaller time intervals. This value of h is very small. And so this last number that we calculated down here, should be a pretty good estimate of our instantaneous velocity right at 0. Okay, so in a nutshell, they're kind of asking you, what does it look to you like these numbers are approaching in our table? So we got minus 0.670 for our first. average velocity, then minus 0.691, and so on. And notice that these two numbers repeated. And so what that probably means is if we kept going with smaller values of h and rounded our answers off, we would probably keep getting minus 0.693 over and over again. And that tells us that that number should be a pretty good estimate of our average velocity. Okay. Instantaneous velocity. Okay, so let's say it this way. From the table, we estimate that the instantaneous velocity right at t equals 0 is negative 0.693. Okay, now one thing that we didn't do in the answers that we did above is units. What should the units be in this problem? Okay, well, if you look at the units that we were given, position was measured in meters, time is being measured in seconds, so we should get units of meters per second. Okay, for all of these velocities that we're talking about. Okay, and maybe one last thing that we could do is to think graphically about what we calculated here. So what is that minus 0.693? Well, it's an idea of what the slope of our graph would be right at t equals 0. Okay, so if we drew in the tangent line, okay, the line that just grazes the curve at t equals 0, that slope should be the minus 0.693 that we just calculated. Minus, not positive. Okay, and there we go.